let's compare the common emitter and common base characteristics of a BJT using LT-Spice. This circuit is drawn to obtain common emitter characteristics of this BJT. We have set the simulation command to vary this source collector to emitter voltages from 0 to say 12 volts, from 0 to say 12 volts for an increment of 0.05 volts, and this change will be repeated for each value of VBE. For one value of VBE, this variation will draw one characteristics curve, as we already know, right? And to select the each value of this VBE source, it would be the second source. So it will start from 0 and stop at 0.7 volts with an increment of 0.05 volts. So it means it will draw first characteristics curve with VBE is equal to 0, second one with VBE is equal to 0.05, then 0.15, then 0.2, and so on to 0.65 and 0.7. Let's simulate. So because we want to uh, draw the collector current with reference to collector to emitter voltage, means this axis should be the voltages from collector to emitter, right? So first we have to see the node number. This node is VN001. So it means this collector current, only this collector current will be displayed when you have clicked for this emitter at the collector. And then this one is V2 source. We have to select it VN001, bracket close, enter. So these are the characteristics curves for this BJT with common emitter configuration, right? And this last curve is with VBE 0.7, VBE 0.65, and to the bottom when VBE is equal to 0. Okay, so now let's draw the characteristics curves with common base characteristic. Okay, so this is common base circuit, similar to the one with common emitter, but at this time you have based as referenced, right? And it means we are going to change VE, not VB with V1. Here with V1 we are going to change B by taking E as 0 or constant, but this time we want to take B as constant or 0, and we have to increase VE to have a change, actually decrease VE to have a change in VBE. I rotated this circuit to make this ground level at the bottom. Otherwise you can take the same one, this one, right? But you have to make base ground. Let's draw characteristics. The same simulation command is selected. We have to vary this one, VCB from -1. We know already that we have to increase from -1 plus 15 with an, you can take this also 12, it's okay, and then increase by 0.05, and this increase will be seen for every value of this VBE, right? The same settings here, and then simulate. This is VN002, so it means we have to select our reference already here, but okay, you can put here, right? This will be your reference voltage. Now, collector current, but with reference to Vn00 to V of have already checked. So these are the characteristics curves, right? Starting from -1, and you have current negative because both the junctions are forward biased. So you have a negative current. Okay, so now we can compare with this circuit. We have IC with reference to VCB. With this circuit, common emitter characteristics, we have drawn IC with reference to VCE. They are equivalent because if we use this circuit and we draw IC with reference to VCB, it's up to us because we see VB and VE. IC, IB, IE. We have everything. So we can draw any parameter with reference to any other parameter, right? But when you have something common, you have to draw any parameter with reference to that common parameter, right? So that is why we call this as common base characteristics curves and this one as common emitter characteristics curves. But you can still draw with this circuit because you have all these values. You can have a plot with something made with reference to something, some other parameter, right? So now let's compare. First thing, what select this point. Okay, saturation point, right? This one is the saturation point. So at the saturation point, you have VCE 0.3, VCE 0.3, and VCB is minus -0 0.4, right? So it means at VCE 0.3, the value of current will be the same at VCB from 0 to negative, it's minus -0 0.4 will be having the same current value, right? So then our statement will be checked, right? What was the statement? Let me state once more. Is that when we took emitter as common, right? So we have drawn every voltage with reference to emitter, right? Base to emitter, right? The input characteristics curve IC versus VBE. So B with reference to E. Output characteristics curve shown here. IC versus VCE, right? So because E is common, but still you can draw VCB. It's up to you, right? Because VC is varying, VE is something constant here, VB is varying, so you can have any parameter drawn with reference to any other parameter, right? Same is here. Although I have changed VCB and VBE, but still I am drawing VCE. Why? Because I know VC, I know VE, so I can subtract it out to get VCE, right? So it means these curves can be drawn with this circuit, but it is better to draw every parameter of a circuit, especially the amplifier circuit, with reference to the common parameter, the referenced parameter. So that's why these curves are called common emitter characteristics curve, right? Otherwise, these curves can be drawn with this circuit. Okay. So let's see. I have changed the simulation command because I just want to run only. Let me show you one thing. No change here. Let's take it 12, and here no change. just what I change is start value is 0.7 and stop value is 0.7. So increment doesn't matter because it will take only one value of VB and then stops. So same is done with this one. Okay, this one also needs to be, let me make it. So this is common emitter one, but Vn001. So this current should be drawn with Vn001. Okay, and this one Vn002. Vn002. Okay, so VCE, this is IC versus VCE, IC versus VCB, right? So it means at VCE point 3, look at here, right? VCE point 3, this collector current value, and what is that? It is 5.371 milliampere. 5.371 milliampere. It should be same at VCB minus 0.4. So VCB minus 0.4 is this value, right? Yes, it would be similar. Yes, it's very, we have to move very precisely. I'm going for, okay, almost 0.4, so it means 5.371, right? So we can draw, so it is checked, right? So the parameter you are varying with reference to something, but all parameters can be, any parameter can be drawn with reference to any other parameter, right? Let me show you here, right? So these curves with this circuit, I can still draw, right? Close it down. And now collector current, but with reference to this need to be changed, right? Let me see, put it here. So it means you should be having Vn001 minus Vn002. N001 minus N002, right? So collector current, but N001 minus Vn002. Same characteristics of PCB minus 0.4. It's nearly 5 point. It's exactly 5.37, right? Oh, I can. Yes, this one, nearly that. Okay, so this actually completes our comparison of common emitter characteristics and common base characteristics, right? So you can draw, because all parameters are varying, you can draw any parameter with reference to any other parameter by using this circuit or by using this circuit. But whenever you plot any parameter, it is recommended to plot that with reference to the common terminal in that circuit. So that's why these curves are called common emitter characteristics, and these curves are called common base characteristics curve, because in this you have IC with reference to VCB. It means based is taken as reference, right? So we have already shown that these curves can be drawn with this circuit and these curves can be drawn with this circuit, because you can plot anything with reference to any other thing. So this is done, the comparison about common emitter characteristics and common base characteristics, right? So let's